Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. Stellar winds. A constant stream from stars. Stars, those celestial beacons dotting the night sky, might appear as distant points of unwavering light. But beneath their seemingly tranquil exterior lies a reality far more dynamic. Stars are colossal furnaces, churning with thermonuclear reactions in their cores. This fiery activity doesn't just generate the light we see. It also produces a constant outward stream of charged particles, a phenomenon known as a stellar wind. Imagine a powerful, invisible breeze blowing outwards from a star, shaping its surroundings and influencing its entire life cycle. This stellar wind is a critical, yet often overlooked, aspect of a star's existence. It shapes the star's environment, interacts with other celestial objects, and plays a crucial role in its evolution. Understanding stellar winds allows us to piece together the grand story of stellar birth, life, and death, offering a deeper appreciation for the dynamic universe we inhabit. Unveiling the elusive stellar wind. For centuries, the existence of stellar winds remained a mystery. Early astronomers lacked the tools necessary to detect these elusive particles streaming away from distant stars. Telescopes, while powerful for their time, couldn't provide the level of detail needed to discern the faint signature of a stellar wind. It wasn't until the 20th century, with the advent of a powerful technique called spectroscopy, that scientists could finally unveil the secrets of stellar winds. Spectroscopy allows astronomers to analyze the light emitted by celestial objects. By studying the way light interacts with atoms, scientists can identify the elements present and even measure their velocities. In the case of stars, the analysis of their starlight revealed a subtle shift in the wavelengths of certain spectral lines. This shift, undetectable to the naked eye, held the key to unlocking the mystery of stellar winds. The engine that drives the stellar wind: nuclear fusion. The energy source that fuels the relentless flow of a stellar wind lies at the very heart of every star: nuclear fusion. Within the scorching core, under conditions of immense pressure and temperature, hydrogen atoms undergo a remarkable transformation. They collide and fuse into helium nuclei, releasing a tremendous amount of energy in the process. This energy creates an outward pressure that counteracts the immense gravitational pull holding the star together. But the story doesn't end there. Not all the energy from nuclear fusion is used to balance the star's gravity. A portion of this energy creates a powerful outward push, a pressure gradient that extends to the star's outer layers. This outward pressure eventually spills over into space, carrying with it a stream of charged particles: the stellar wind. The intensity of the stellar wind depends on the star's mass, temperature, and stage of life, but its presence is a constant reminder of the dynamic processes churning within these celestial giants. The ingredients of a stellar soup. Composition of stellar winds. Stellar winds aren't simply a uniform stream of air. They're a complex cocktail of charged particles, each with a story to tell. The exact composition of a stellar wind varies depending on the star's characteristics, its age, mass, and temperature. Imagine a recipe for a cosmic broth, where the ingredients and their proportions determine the wind's character. For most stars, the primary constituents of the stellar wind are protons and electrons, the fundamental building blocks of atoms. These charged particles, stripped of their outer electrons, are whipped outwards by the star's internal pressure. Additionally, the ongoing nuclear fusion process within the core plays a crucial role. As hydrogen fuses into helium, the reaction releases alpha particles, essentially helium nuclei. These alpha particles also join the ranks of the stellar wind, adding to its overall force. The recipe becomes more complex for stars that have undergone significant evolution. As a star ages and exhausts its core hydrogen fuel, it might start fusing heavier elements like carbon and oxygen. Traces of these heavier elements, along with any elements already present in the star's makeup, can also be swept up in the stellar wind, enriching the interstellar medium with a wider variety of materials. Shaping stellar destinies. The impact of stellar winds on evolution. Stellar winds are more than just a curious phenomenon. They play a crucial role in shaping the life cycle of stars. Over vast timescales, these persistent winds can slowly erode a star's mass. For stars like our Sun, with a relatively low mass, this mass loss is gradual and has a minimal impact on their overall lifespan. They might puff out a steady stream of charged particles for billions of years, with minimal change to their overall structure. However, for massive stars, the story takes a dramatic turn. Stellar winds can be incredibly powerful for these giants, stripping away significant amounts of mass throughout their lives. Imagine a massive star constantly shedding layers, like a peeling onion in space. This mass loss can have a profound impact on the star's evolution and ultimately its fate. As the star loses mass, its core becomes more exposed, and the balance between outward pressure and inward gravity starts to shift. This imbalance can set the stage for a spectacular, yet catastrophic event, a supernova explosion. The grand finale. Stellar winds and supernovae. The influence of stellar winds becomes particularly dramatic towards the end of a massive star's life. As the star ages and begins to fuse heavier elements in its core, the stellar wind intensifies. This mass loss plays a critical role in triggering a catastrophic event, a supernova explosion. Imagine a ticking time bomb fueled by stellar winds. When a massive star loses enough mass and its core can no longer withstand the crushing weight of its outer layers, A dramatic sequence of events unfolds. The core collapses inwards under its own gravity, while the outer layers, no longer held in check, rebound outwards in a colossal explosion, the supernova. This explosion can be billions of times brighter than the star was in its prime, outshining an entire galaxy for weeks. The powerful shockwave from the supernova then propels the stellar wind material outwards at even greater speeds, enriching the interstellar medium with the star's elements and potentially triggering the formation of new stars and planetary systems. In a sense, the stellar wind, which relentlessly eroded the star throughout its life, becomes the driving force for the creation of new celestial bodies in the aftermath of the supernova. The stellar wind's legacy lives on, shaping the future generations of stars and planets. Stellar winds, sculptors of nebulae. The relentless flow of stellar winds doesn't just affect stars. It leaves its mark on the vast canvas of the interstellar medium, the space between stars filled with gas and dust. As stellar winds interact with these interstellar clouds, they can compress and sculpt them, triggering the formation of spectacular nebulae. These nebulae come in various shapes and sizes, from the delicate wisps of the Veil Nebula to the intricate pillars of creation in the Eagle Nebula. Imagine a celestial sculptor using the powerful winds of stars to shape vast clouds of gas and dust into breathtaking formations. The sculpting power of stellar winds depends on several factors. The strength and direction of the wind, the density and composition of the interstellar cloud, and the presence of nearby stars all play a role in shaping the nebula's final form. In some cases, the wind might gently nudge the cloud, triggering the formation of filamentary structures or sweeping cavities within the gas. In other instances, a powerful wind can compress the cloud so intensely that it ignites new star formation within its dense pockets. The intricate structures observed in these nebulae, from towering pillars to glowing bubbles, are a testament to the sculpting power of stellar winds. Earth's fiery shield, the solar wind. Our Sun, like all stars, also has a stellar wind, but we call it the solar wind. The solar wind is a continuous stream of charged particles emanating from the Sun's outer atmosphere, the corona. While the solar wind pales in comparison to the powerful winds of massive stars, it still has a significant impact on Earth and its surroundings. Imagine Earth constantly bathed in a stream of invisible particles from the Sun. The Earth's magnetosphere, a magnetic shield generated by our planet's core, protects us from the brunt of the solar wind's bombardment. This magnetosphere acts like a giant shield, deflecting most of the charged particles away from Earth's atmosphere. However, the solar wind can still interact with the magnetosphere, causing auroras, northern and southern lights, to dance across the polar skies. These dazzling displays of light are a visual reminder of the constant interaction between Earth and the solar wind. Beyond Earth's atmosphere, the solar wind's influence. The solar wind's influence extends far beyond Earth's atmosphere. It shapes the structure of the solar system, interacting with comets and asteroids and influencing their trajectories. As comets approach the Sun, the solar wind heats up their icy surfaces, causing them to develop tails that stream away from the Sun. The solar wind also plays a role in space weather. When the Sun experiences periods of increased activity, it can eject powerful bursts of solar wind and charged particles known as coronal mass ejections. These ejections can interact with Earth's magnetosphere, causing disruptions in communication systems and power grids. Understanding the behavior of the solar wind is crucial for predicting and mitigating the effects of space weather on our technology and infrastructure. A window into stellar evolution. The legacy of stellar winds. Stellar winds offer a valuable window into the inner workings of stars and their evolution. By studying the composition and velocity of stellar winds, astronomers can gain insights into a star's mass, age, and stage of life. The presence of certain elements in the wind can indicate ongoing nuclear fusion processes within the star's core. Additionally, the strength and variability of the wind can provide clues about the star's stability and potential for future events like flares or eruptions. The study of stellar winds is not just about understanding individual stars. It's also about piecing together the grand narrative of galactic evolution. Stellar winds play a crucial role in enriching the interstellar medium with the elements forged within stars. These elements, scattered throughout the galaxy, become the building blocks for future generations of stars and planetary systems. In a sense, stellar winds act as a cosmic recycling program, ensuring a continuous cycle of creation and evolution in the vast expanse of the universe. By studying stellar winds, we gain a deeper appreciation for the dynamic processes that govern the birth, life, and death of stars, and ultimately, the ongoing story of our own existence in the cosmos.